GMAT all day.
Now let's do a question where we have to solve for our exponent or solve for the variables in the powers of our exponents. So when I see a question like this, I am so happy because this is everything that I am looking for on the GMAT. I am looking for questions that I am going to find easy that other people will find hard. And so the reason a lot of people will not be sure what to do here is because I remember from middle school and maybe early high school, the way to solve this. So if I have something like 3 to the x is equal to 5, the way that you solve for x when it is x is a variable in an exponent is the power of your exponent is to use logarithms. I have no recollection of what logarithms are or how they work. I just remember that they were used to solve for variables in your exponent. And I also remember that I usually used a calculator to solve for them, which you do not have on the GMAT. And so logarithms are definitely not a GMAT topic. So how do you do something like this? Well, one thing you could do is you can say, I know that 3 to the first is equal to 3 and 3 squared is equal to 9. Therefore, x must be between 1 and 2 over here. And because 5 is closer to 3 than it is to 9, x is probably closer to the 1 than it is to the 2. And so x is probably an estimated, it's around 1.25 or something. But that's not really solving for x. That's just sort of estimating. However, so there really is no way to directly solve for x here. But if I were to give you something like this and say 3 to the x is equal to 3 to the 7th, what is x? Well, then almost everybody would instantly say, oh, x is equal to 7. Why is it? Because your bases on each side match each other. So therefore, the powers on each side must also match each other. And so in this case, you have not really solved for x, and you really haven't used any sort of mathematical solution for solving for x. You sort of just got lucky, and you lucked your way into the answer because you had this serendipitous condition where the bases on the left side matched the bases on the right. And so when I see something like this on the GMAT, I know that I can't really solve it this way. And so it has to be a special circumstance where I can rearrange this to get something like this. I can get the two sides of my equation. I can get the bases to match up. And the way that I do that, if I want to ensure that everything is simplified and that anything that can be combined or canceled out so that I'm only left with everything that is only absolutely necessary on each side of my equation, is to break up my bases into their prime factors. So when I see a question like this, the reason I am so happy is because I not only know that I can get this question right, I know exactly how I'm going to do it. My strategy is always the same. Break up my bases into their prime factors, then combine things however I need to get my two sides to match. And then I can just easily find solve for x and y in this case. So it looks like on my left side, my bases already are prime. Let me first just write out this whole thing again. $75 raised to the x times 15 raised to the y. So not much I can do with the left side because my bases are already prime. So let's break up the right side. So 75 is 15 times 5. 15 is 3 times 5. I can write this as 75 raised to the x is the same as 3 times 5 times 5 raised to the x. And then 15 is just 3 times 5. So it looks like I know I'm on the right track because now I have some 3s and 5s on my left side. And now I got a bunch of 3s and 5s on my right side as well. So now we just got to use our exponent rule. So what do we say here? When we have a quantity raised to a power, this power just it gets distributed to all the values within our parentheses. So this would just be 3 to the x. This is just 5 squared. So 5 squared raised to the x's times 5 to the 2x times 3 to the y times 5 to the y. Now if I combine, because now I have exponents with the same base that I am multiplying, so 3 to the x times 3 to the y, that just becomes 3 to the x plus y. And then 5 to the 2x times 5 to the y is just 5 to the 2x plus y. Now I have exactly what I want because my bases on each side line up identically. And so I always like ordering my bases in ascending order. Then they're easy to match up. Here, it's not that hard to do. So now I just got to set my powers that are equal to each other and solve. So I know 3x minus 7 must be equal to x plus y. 4y plus 1 is equal to 2x plus y. If we go back to the original question, it's asking for x minus y. So there's two ways you can do this. So I wouldn't rephrase this necessarily as, okay, I need to find x and y. If I can find, x minus y is equal to 10. Well, you don't know what x is, you don't know what y is, but you solve for x minus y. Or it's still possible though that I can get this. It doesn't necessarily mean this is how gonna be done. If I can solve for x and y individually, that is just as good. And that looks like what is going to happen here because I have two equations with two variables. I should be able to solve for each of those two variables. So let's try and do that. I think I can first simplify these guys a bit. So here this is saying 2x minus 7 is equal to y. So y is equal to 2x minus 7. And then this guy here, saying 3y is equal to 2x minus 1. So what should I do here? So it looks like I can solve, if I subtract these two equations from each other, I can solve for y very easily because my x's will cancel out. So y minus 3y is negative 2y. 2x minus 2x is 0. And I have negative 7 minus negative 1, which is really just minus 7 plus 1. So negative 2y is equal to negative 6. Y is equal to 3, it looks like. If y is equal to 3, I just got to plug that into one of these. 3 is equal to 2x minus 7. X is equal to 5, it looks like. Let's check if it works for this bottom one. So 9, 3y is equal to 9. Is equal to 2 times 5 minus 1, which is 9. So it looks like this is good. Y is 3, x is 5. We're looking for x minus y. 5 minus 3 is 2. A. We'll use this most likely on multiple questions on the GMAT. Again, this goes back to not only why exponents are important, why primes and divisibility, the ability to break things up into their prime factors, is a very useful skill that you will use in many different contexts.